Good afternoon, all. Today we are going to learn about advanced technique of age detection. In last lecture, we concluded that gradient can be used for age detection, but it has the issue that first order derivative and second order derivative reacts to noise. Though first order derivative reacts lesser than the second order derivative, but anyway they have some sensitivity to noise, so that was the issue. Second issue was like scaling of image, like scale, like it is zoomed in or zoomed out also matters. So that issue of scaling is new for us. Noise we can understand, we have seen so many times, but issue of scaling is new. Who proposed that idea, that who bring that idea into the light? That it was brought by Mar and Hildreth. They are two scientists, we can say. They worked over on this segmentation part of image, and they concluded that image has scale dependency, right? Here, so what is the scale dependency that you can see? What I want to identify here in this image, these two are this this one is zoomed in version of this portion. If I will zoom in, I am going to get this, right? Now, if suppose I want to find out ages here, what is my expectation? So I am expecting this blur ages, this ages. I'm expecting this age. When I say I want to do image segmentation, I want to segment this garden part from this pool part, right? Or this garden part I want to identify, right? Now, suppose I'm working on this image. The image is same, just it is a zoom version, or get the scaled version, zoom in version. Then what I'm interested in, I am interested in this lines. I am interested in how my grass is separated by other grass. That can be my requirement, right? I want to see whether it is affected by some disease or not. That kind of thing can be the requirement, right? Here my requirement is to find out the small details, while here my requirement is to find out the blur ages. Now use your logic and tell me that in which case I should use larger okay, so in which case I should use the larger mask, right? Mask size will be larger in which case? Suppose I am using a small mask here, right? What I want, I don't want the small details. I don't want the small details, right? So if I will use small mask, I know that it is going to react to small details. All the details smaller than this is going to get suppressed. Mask size matters, right? Suppose I'm using a mask size which is larger than which is what we can say, which is larger here and smaller here is our requirement. The reason is, here I want small details, here I want the blur details. I don't want the small details available here. The same details is available, but here my requirement is to have the small details. Here my requirement is to have blurry edges. So if I want blurry edges, that means I want to suppress small details. And if I want to suppress small details, I will need a larger mask. That is what our conclusion is. So larger operator is required to detect the blurry edges, and smaller operator is required to detect sharply focused fine details, because details are very small. And if I'm using larger mask, all the details smaller than that mask will get suppressed. So I'm not going to get the smaller details. That is quite logical, right? So that was a very obvious observation that we already had, but that affects in your age detection, that was proposed by Marr and Hildreth. So they identified the issue, right? So what they say, that operator for age detection should not be used same for detecting the blurry edges and for detecting this type of fine details. We should use different type of operators for the age detection in both the cases. Here they should be larger, all right? And okay, so and intensity change will react to first order and second order derivative, and you can find out zero crossing in the second order derivative. That was their second conclusion, but of course that we have already seen, right? Major contribution was regarding to the scale, right? So now, based on that, they proposed one solution. They proposed one solution that is known as Marr Hildreth age detector, and that is also known as advanced technique of age detection. So it deals with the noise as well as the scale. Both the issues that were presented here is handled by Marr Hildreth age detector. How to handle noise? We know how to handle the noise. we have to blur the image first. If we will blur, that means we are smoothing our image, that means we are removing the noise. I can use any of the filter for removing the noise, but it will blur my image. I can use, if you can recall, that geometric mean, arithmetic mean, alpha trim mean filter, low arithmetic mean, that is a low pass filter. In the low pass filter also we have several options like Gaussian and that Butterworth, and ideal one, that is standard box filter. We have so many options, right? So we can use any of that filter for blurring, right? What they suggested in their task, that we know that suppose if I will use ideal filter, then ringing effect is going to take place. For the Butterworth, Butterworth will give us this decent amount of blurring, but my requirement is not to blur here. My requirement is to suppress the noise only. So my requirement here is not to have blurring, heavy blurring. That's why I will not go with the Butterworth or ideal. I will go with the Gaussian, because the Gaussian gives us the least blurring possible out of all available filters. So what they suggested, because here I just want to suppress the noise. My intention is not to blur the image. That's why I should go with the filter which blurs the noise but not the details. That is, blurring is in the controlled manner, and that is possible in the Gaussian that we have seen earlier in the previous chapter. So they suggested, okay, so they will use Gaussian. What is the Gaussian equation? So their Gaussian equation is e raised to minus x square by 2 sigma square. And if they are two dimensional, then it is e raised to minus x square plus y square divided by 2 sigma square. This is the equation of Gaussian, if you can recall. This was the same equation that we had in the frequency domain. If you can recall that if I want Gaussian in frequency domain, I will need Gaussian in time domain as well. That's why I'm using this partial domain representation as a Gaussian, because I want Gaussian in frequency domain so that blurring will be limited. So I will find out its inverse Fourier transform, but I know Gaussian's inverse Fourier transform is Gaussian, that we have already concluded last time. So I will use Gaussian in spatial domain as well. What is x and y? They are coordinates. So suppose there is my image, and if I'm starting my coordinate from 0 to m minus 1, so my coordinates are 0 to m minus 1, right? And this is 0 to n minus 1. And I'm assuming this is my window. Window is of 3 cross 3 size, right? So your m and n is 3 cross 3, or small n if you want to use. This is window, your window that you are going to convolve with your image. Partial domain it is, right? So if you want to work with the small m and small n, that you can follow the same notation that we are used to, right? So what I will take, I'm deciding that I'm going to use the Gaussian of 3 cross 3 size, right? So how to obtain the values of this filter? So I know that what is the value of x and y here? They are 0, 0 here. So I will substitute 0 and 0 here. Whatever the value I will obtain, that value I'm going to put it here. Same way I will go for the next one. Here my x is 0, y is 1. So and I can change for all the xy values. For 3 cross 3, it will be just 3. I hope you can understand it. X value will vary from 0 to 2, y value will vary from 0 to 2. Substitute all the values and get all 9 elements of this mask. So that mask you have, now what to do with that mask? Just move to have the padding of your image, then start with the first element and then have element wise multiplication, then add it and replace it with the center location. That is how you can apply the Gaussian to um, that is how you can apply Gaussian to your in spatial domain. So what will happen if you are applying Gaussian in spatial domain? You are applying Gaussian in frequency domain as well, because frequency domain representation of Gaussian is Gaussian itself. So I got the purpose, that blurring in required limited amount I obtained. Now, two questions remains, that okay, you blurred it. Actually, you wanted to find out ages, but you blurred it. Why you blurred? Because I wanted to suppress the small details, right? So here, if I want to suppress the small details, and here I don't want to suppress much. So here my Gaussian mask size will be smaller, and here my Gaussian mask size will be larger. Why? Because I want to suppress more details here. That's why I need a larger mask compared to the previous case. So here I concluded that my mask will be of 3 cross 3 size. Actually, it is not the case. It will be scale dependent. It can be your n cross n, right? It will be your n cross n. And how to decide the value of n? That is a method that we will see. How to decide the value of n? That is a remaining job, right? But so what is that method? I'm repeating the method so that you can conclude better. I want noise and scale issues of. I want to remove the issues of noise and scale. To remove the issue of noise, I will use blurring. But how much blurring to use? Limited amount blurring. That's why I will go for the Gaussian. Right now, but Gaussian will blur definitely. It will suppress the details definitely, but it will depend on the scale as well. I should not use the same filter here and here because I want to suppress more details here. So I should use my mask larger of this size. So though I am going to use Gaussian, but what will be its size? That will be scale dependent. Okay. So okay. Now tell me in this case, if you will observe these two images. Now tell me in which case, if I say this is image A and this is image B, in which case variance is higher? In case A or in case B, variance will be higher. Variance is what? The average intensity values. In case A or in case B, variance will be higher. Yes, in case A, the variance will be higher. So now what I want, if higher the variance, I need a larger mask. That is what my conclusion is. That will happen if I'm having more details involved. If I'm having zoom out version, then more details will get involved and variance will be higher anyway, right? So what will happen if my variance is higher? I need a larger mask size. That means my mask size small n depends on variance of my image. And how it is dependent? So that value is proposed by them, that Mar and Hilder, they have proposed. What is that value? That value is given by that 6 sigma. 6 sigma. Sigma is your variance and your mask size is the smallest odd integer greater than or equal to 6 sigma. So suppose my sigma is a 4, right? My sigma is a 4. So what will be 6 sigma? It will be 24. What will be my mask size? It will be 25 cross 25. Why? Because it is smallest odd integer, right? Over this 6 sigma. Smallest, because you know that we take n cross n, which is n is odd in that case, right? So why it is dependent? So they suggested 6 sigma. Someone will say, no, I'm not interested in 6 sigma. How you can go with 6 sigma? I will go with 8 sigma, 9 sigma, any value. But the reason they proposed was that majority information of my Gaussian lies in plus or minus 3 sigma. That is, in the span of 6 sigma, majority information lies. So if I want to blur majority of information, so I should go with the 6 sigma. That is their conclusion was. That is their proposal was, right? But not necessarily the Mar-Hildreth procedure. Then you will go with the 6 sigma. But if you want to have modified version of Mar-Hildreth, you can go with your own value, right? And here they are also saying that any smallest odd integer they have taken. Here it is 24. You can go with 31 cross 31. That is all right if it is your requirement, right? But when I say it is Mar-Hildreth, it should be 6 sigma. Okay, because that is their proposal. That is the research, right? Okay, so that is how it is completed here for the noise and the scale. So you will say, okay, noise and scale we handled using Gaussian, that we understood, but here we didn't find the edges. We are not here to blur. I agree, we are not here to blur, but we did this blurring to handle noise and scaling. Now what we have to do, we have to actually find the edges, right? So for finding edges, what I will do, I will apply Laplacian over the Gaussian. So first I will take my image. Then I will apply Gaussian over it. So it is blur now. Now I want to detect the edges. To detect the edge, I need a first order or second order differentiation. I can use any, but I'm going to use the second order differentiation. Again, you will say why to use second order? Why can't you use first order? Again, that was their suggestion, their research. If you want, you can change according to your requirement, right? But Mar-Hildreth, they suggested because they wanted thin edge because we have blurred. They feel that if the edges are blurred, noise will be less effective. So we can go with the issue of the second order differentiation, that it is more sensitive to. That noise is removed because now noise is not there, right? So that issue is solved here, and hence they can go. That was their idea, that we can get the advantage of second order differentiation, that thin edges we can obtain, because ultimate goal is to obtain thin edges. So they applied. So Gaussian was applied, but not only Gaussian. I want to apply Laplacian over it. What is Laplacian? It is second order differentiation in x direction of my function, second order differentiation in y direction of my function, right? What was my function? Function is g of xy. It is given by this. Suppose I find out first order partial differentiation with respect to x. What will be that value? What will be that value here? It will be e raised to minus, y will be considered as constant. I want to find out this value, that differentiation with respect to it, and again differentiation with respect to x. So this is actually two times differentiation of my g function with respect to x. Only x partial derivative, you know very well. So here I will consider this as a constant, so I will not worry about. So differentiation of exponential is exponential itself multiplied with whatever the term, the additional term you have, or in whatever modification in the regular expression you have. So what it will be? Here it will be minus 2x by 2 sigma square. 2 will get cancelled, and hence it will be minus x by sigma square. That is the first order differentiation of g of xy with respect to x, partial differentiation with respect to x. Now we are going for the next one, that is second order, second time we will have partial differentiation. Here we will need to apply the rule of chain, right? Multiplication rule we have to apply. So what we will do, we will first partially derivate this, and we will keep this as it is, minus we will, or plus we will multiply, we will keep this as it is, and we will have differentiation with respect to this. So what we are going to have here is, this will be our solution. You can check, you can verify what this will be. And this differentiation, this is for 1 sigma square into this as it is. And what about this? What you will obtain here? It is 2 sigma 2 what it will be, 2x square, and 2x divided by 2 sigma square, so it will get cancelled, but x by sigma square is already there. It will get multiplied here, so you will get x square by sigma raised to 4, right? So I hope you are comfortable with this type of differentiation. If not, we can explain, but I don't think this is difficult. You just apply the chain rule. What it is, first you derivate, have the derivation of this, keep this constant, then you can subtract it from, keep this, then you will have this differentiation. I mean, you will keep this as it is, and you will have differentiation of this, and this result you will have for that. Same thing you can have for y direction, partial order differentiation, and if you combine this, your expression will look like this, and this expression is known as Laplacian of Gaussian. This expression is known as Laplacian of Gaussian. That is Laplacian of Gaussian. So now if I want my log filter, now my specific filter I have, right? Now I don't have Gaussian, I don't have Laplacian, I have specific filter, and I will have x. And if I want to find out what is the value of this at this location, then I will substitute x value 0, y value 0, sigma value whatever I have, and I will substitute those values, and I will obtain the value for this location. Same thing I will do for the next one. Same thing I will do for the next location, right? And for all the xy value, that is my, if it is my 3 cross 3 that I have selected, my filter size will be 3 cross 3. I will get the values here for different, substituting x and y values. So if I take different values of x, if I take different values of y, I substitute them, and if I plot the curve, it looks like this. The operator looks like this. If you will see from top, the image of that will look like this. That is high here, here dark zero values, and again some zero values, but these were negative, right? So that impact you can see here. And side, if you will want to see the profiles, then profile will look like the profile. I hope you can see that profile. The profile is like this only, right? So that profile you can see negative values, positive values, negative values, and zero values, right? How to obtain this? So to obtain this, what you can do, you can substitute different values of x and y here, and you can get the value. That's fine. Here my, it is 5 cross 5, or I will substitute x and y from 0 to 4, and I will get the value. That's all right. Or intuitively you can have that center is having highest value, then it is decreasing, then it is going, so center value is having highest value, then it is having negative value in surrounding. You can see the negative value in surrounding, and then values are slightly increasing. So values are slightly increasing. So this is how you can have this value is -1. Okay, so again the question arises, why to take this as 16? The 16 you have taken because if you will sum this up, all the elements, the summation will be 16, right? And so if I will apply this mass to a constant region where all the intensities are same, that means no edge is present. My response of my edge detector should be 0 because there is a constant region. There should not be any edge. So summation of all the elements of my edge detector must be 0. That you can observe in Laplace. That you can observe in in Sobel, Privit, any edge detector, if you will see, if they are applied to constant region, the result must be zero. That we know that is the property of first order and second order differentiation, right? Why so? What is the significance? That constant region doesn't have edge. That's why we should not have any response there. So if I apply to this constant region, I have to set this element such that the summation should be zero. The summation of all the weights should be zero. Okay. Now, next question arises. Okay, why you took 16 here and minus 2 here? Why can't you take another value 32 here and 4 here? 4 here and 32 here, then also it will lead to the similar type of structure. Why you took 5 cross 5 only? Why you took this? All this type of questions are there. But again, what is the solution? The solution is the same that we had, that this is the proposal by Mar and Hildreth. If you, this is the idea. Idea is from the Mar and Hildreth. If you want to modify and you want to go with the larger mask, of course you are free to go. This is just an experiment, right? And their suggestion, this is sufficient. Suppose someone will say, okay, why can't we go for the larger mask? If we will go with the larger mass, what will happen? The more element wise multiplication, more additions, more replacements, I mean, scanning time will be higher, right? So they found that this mask is of 5 cross 5 is sufficient. But if you're in your application, if you feel that it is not, then you can go with another example as well, right? In another mask as well, right? Now, okay, so and this is also known as Mexican head operator. Why? Because its shape, if you will see, it is looking like a Mexican head, right? So this operator, that LOG filter, is also known as Mexican head operator. Okay. Now, um, what we had here, we can conclude that I will use this operator. I will use this operator. What is that? This is LOG operator. How we obtain? We obtain by taking Gaussian and having Laplacian of it. So this is how we obtain this. And if I will use that operator, and if I convolve it with my image, that this mask shifting of that and multiplying with each element and all that regular filtering operation, if I apply convolution, then I will get the image which will have better edges. That is a better edge detection I will obtain here. That is what their point is. Then they continue with their experiment, and what they said, that it is not like required that you use LOG filter only. You can have your experiment like you can take your image, first you apply Gaussian and then you apply Laplacian. Instead of taking a separate operator of LOG, which combines the characteristic of Gaussian and Laplacian both, what you can do individually, you can go with the Gaussian and then you can apply Laplacian. That is what very basic logic says, that take your image, blur it, and then you find its second order differentiation, that is edges you can find. So that also gives very convenient, comfortable results, right? So they further gave the idea that if I am going with this, then what should be the size of my Gaussian? The Gaussian size, as we suggested, it should be of n cross n, and it will be that smallest odd integer greater than 6 sigma. So you can take your Gaussian of n cross n size, and what will be the n value? That can be decided by your sigma. Then you can go with the Laplacian of 3 cross 3 mask. So according to us, that operation is over. That you just blur it and then you apply age detection, and you should have better ages because small details are suppressed now. So our idea says, or our concept says that this is sufficient for us, but practical implementation required one more step of that, that is zero crossing. Why that zero crossing took place, that we can see. Suppose there is a edge or there is a line in my image like this. Suppose this is my line, or this is my some, or we can say it is part of my edge, right? Or rather, if not, then I can explain you with the line only. That will be even better to understand. So this is the line. Now what I'm doing, I am finding, I'm blurring it. So all small details in the surrounding is suppressed. So Gaussian is applied. Now I am applying that Laplacian. What Laplacian says, actually it finds the difference, right? So if I am finding difference with this two, and so it is a constant region, I am going to have a zero response. Here also the difference between these two will be zero. Non-zero difference will come here. So here, if I will see here, so in this location I am going to have the non-zero difference, right? So I will obtain non-zero difference at this point, right? Same way, then what will happen in the next location? What will happen? In the next location also, now my transition is from the positive to negative. So again, I will find non-zero difference there, right? So if I will do that operation for entire one, I am going to get the shape like this. If it is a little thicker, I'm going to get the shape like this. Instead of having line, single line, I'm going to have a loop kind of result for this line. Why? Because when I will take difference on this direction, it will be non-zero. Then from going from this to this direction, also it will be non-zero. So loop kind of impact I'm going to have, right? So, but I know when I will go from this direction, it is from zero values to positive value. It is increasing here, and now here if I'm going, then it is positive to zero value. So a transition, though it will be non-zero value, but here this line will be positive, suppose, and then this sign of this line will be negative, right? So if I want to find out, if I don't want loop kind of edges to be detected, then I want a single edge that is in the center here, if I want that, what to do? I have to find out zero crossing here. How? That if there is a positive pixel on my this side and there is a negative pixel on my this side, then take center value. That is how you can find out zero crossing. Okay, so so that we can conclude again here. We can see that here. See, if I'm not applying zero crossing, this type of loops I can see. This is not a spaghetti effect, because if you will see, your image will look like it is a dish of spaghetti, right? So here you can see the loops are identified, but I don't want loops. I want a single line here. If I just want a single line here. So I know whenever I will have this type of loops, why this loop will exist? This loop will exist because of transition from zero to positive and positive to negative. And what is the advantage of the second order differentiation? It is that if transition is from positive to zero, then the sign will be different, and transition is from zero to positive, then the sign will be different. So zero crossing, if you are finding, then center element you can easily find out. So how to find zero crossings? So you will check that suppose my pixel is there, then I will check what is the sign of this left side pixel and what is the sign of right side pixel. If it is different, right, and so if it is not different, then it's all right. Then I will check for the top. What is the sign of the top pixel? What is the sign of bottom pixel? Same way you can go for the diagonal as well, but they have not suggested. They are taking just four top, or up and down, left and right, right? But if you want to take for diagonal, that will be your proposal, right? So I suppose I am taking this two, and I am taking I'm checking this two, but they are having equal sign. So it is not a zero crossing, but they are having different sign, right? So I will consider this pixel as my zero crossing, and I will mark it, instead of having this value non-zero and this value non-zero, I will mark this as my edge pixel. But what I will consider while I will do this, that suppose this value is -1 and this value is say +6, then I can understand, okay, it is a zero crossing. But suppose this value is -1 and this value is +1, that means it can be the issue of some noise or something like that. Difference is not significant. Possibly they are not zero crossing, right? So when the difference is numerical difference between those two pixels, top and bottom, or we can left and right, is greater than threshold, or significant difference if they have, that means it is a zero crossing. Otherwise, it can be the reason of the noise, and that's why that one pixel is only negative. So I should not consider this. I should consider this as it is, right? Now, that is what that is what we can see here. That Marl test detector. Original image, then we applied blurring of this, then so Gaussian is applied, then Laplacian is applied. Gaussian of n cross n, how to obtain n, that I will find out variance of this. I will take 6 sigma, and I will take smallest odd integer greater than 6 sigma to get n value, right? Then I will apply Laplacian of 3 cross 3, up to this is then I will apply Laplacian of this is blurring, and then if I am applying Laplacian of suppose I am applying this is Laplacian and Gaussian, right? Here it is Laplacian and Gaussian. Now this is scaled version, so your negative values are considered zero. But I don't want that, because I want edges like this, where background is black and edges are Right. So this is more useful to me. So if I will convert that into considering all positive and negative values, that means taking absolute value here. So I'm going to have this type of loop impact. What is the meaning of it? That was hidden here. That you can see it was available. It was there. You can see that loop impact here. But why it was not visible? Because we took positive values positive and negative values as zero. Scaled version applied, but this is not the result that I need for the for human interpretation. This is fine, but for computer I need this type of result where background is black and foreground is or edges are white, right? So for that zero crossing was applied on this and results are obtained after thresholding, and the results are like this. So three steps: Gaussian, Laplacian, and zero crossing. One more point is that not necessarily you further they continued the research, and what they said, then not necessary to use log, not necessary to apply Gaussian first and Laplacian later. You can go with difference of Gaussian as well. Then also you will get the similar kind of structure or similar kind of Mexican head operator. So if you don't want to go with Laplacian because it is a second order differentiation, and if you want to go with two difference of two Gaussian, one Gaussian is having variance sigma 1, another Gaussian is having variance sigma 2. Then if you will take difference of this Gaussian, and then it will, if you will take the difference of the Gaussian, it will give us the curve. Suppose I am taking different values of x and y, and if I am plotting it into that Cartesian scale, if I am plotting it, so I will get a shape, and that shape will be equivalent to log of sigma. Log will have sigma. Log will have the sigma, right? Log must have the sigma here, but this is sigma, and that sigma, and how the sigma 1, 2, and that sigma of log will relate. They will relate by this equation. Okay, so so that is how they showed that if this is the solid curve is of log filter, right? And this is and this the dotted curve, if you can see, it is obtained from dog, right? So if I say dog curve I have used with sigma 1 and sigma 2, then this Laplacian is obtained using the sigma, and how to obtain the sigma value using this equation, right? Now you can see that if I have taken sigma 1 and sigma 2 ratio, and if I am taking 1.75 to 1, that sigma 1 and sigma 2 ratio, if I am taking 1.75 to 1, I am obtaining this. And if I am taking that ratio 1.6 to 1, that is sigma 1 is 1.6 times sigma 2. If I am taking that type of ratio, then I am getting the curve which is more nearer, if you can observe, to LOG. So what is this what they suggested, that you not necessarily you should use the log, or not necessarily you use Gaussian and then Laplacian or dog. Any of the method that is convenient to you, you can go with that. The concept is it should have Mexican head kind of shape, right? So that is all about Mar-Hilrath edge detector. How it handles scaling by changing the size of n. Okay. So any doubts so far? Anything that you want to get repeated? Okay, so now we are going towards the next edge detector, that is Kenny edge detector. Okay, so what are the objectives of the Kenny edge detector? It should have low error rate. What is the meaning of low error rate? That whatever age you say that is a edge detector is going to find out ages, right? When you say it is age, it should be age. It should not be erroneous output. It should be your age. It should be your true age. Now, when you locate the age, I say here that age is existing, and it should be very near to the actual age as well, right? It should not be like I am detecting the age, but it is far from my, suppose this is my object, right? I will detect this age, that's why it is true age, but I am detecting it somewhere here. That should not happen. The distance between detected age and actual age should be less. It should be near to the actual age. So that is the second objective. And third is it should be single point response or thin edges I want. We don't want to go with the thick edges because thick edging misleads, right? So how to handle these three issues? For that, they took first smooth the image because noise is going to be there. So you have to smooth it, and why to smooth with Gaussian, that we know now. So we will smooth it with the Gaussian. Then we will find out its gradient magnitude and gradient angle to detect the edges, right? So you may ask me that just you said you want thin edges. Now you are finding gradient. You are finding ages using gradient. Gradient is first order differentiation, and first order differentiation is known for the thick responses. How this will meet Kenny's objective? That is a good question. For that, we need two next steps. That I need to do non-maxima separation, and then I have to do double thresholding. What are those steps that we will learn? Just a few minutes after we will learn. But let's see first two steps. First step is apply Gaussian. See if I am writing Gaussian. How to write one dimension Gaussian like this? If it is two dimension plus y square will come, right? That you know. So if I am having, if I am finding Gaussian, it will be e raised to minus x square plus y square divided by 2 sigma square. That type of filter I am going to apply. Then I will apply gradient. What is gradient? Gradient is first order differentiation. So that is what it is. So this is the concept of Kenny. Take Gaussian, apply first order differentiation. This is in one dimension. If you will do this in two dimension, then it will be for image. So again, let's do that for two dimension. First take Gaussian, apply, right? And then find gradient of it. You can use Privet, Sobel, any mask that you want to use to find gradient. Then you can find out magnitude and angle using that Sobel mask and Privet mask. You know that we have discussed in last lecture already. Okay, so this is how you can find out magnitude and you can find out the phase. Okay, now so now what we are expecting here, that small details are suppressed and edges are detected as thick edges by these two steps. Now our next step says that it should be that is non-maxima suppression. Now to understand that, let's take this example. Suppose I am having thick edges are detected. So I am giving you this example. Okay. This is how edge is detected. This is one of the response after Gaussian and gradient. Assume that this is that result. Can anyone tell me it is vertical edge, horizontal edge, diagonal edge, which kind of edge it is? Can you see the edge here? Which kind of edge it is? Can you see the edge? Yes, it is a vertical edge. Background is 0. Here it is non-zero. So this is my vertical edge, that is non-zero response for the edge is detected, and it is a vertical edge. Right? So this is our one observation. It is thick vertical edge. Now what is non-zero suppression? I will take my pixel of my edge. Right? I will check, or rather I will take any pixel. Fine, that's all right. I am taking any pixel and then I will check uh, is it smaller or any element larger than this value exist. If yes, then suppress it. If it is not a maximum one, suppress. Non-maxima suppression. Take a pixel, observe, is it maximum in its neighborhood? If yes, then keep it, otherwise suppress, make it 0. So 1, I will check it. Is it 0? It is greater than 0. Yes, so it is greater than 0, but it is less than 2. That means 1 is not the maximum one, and hence I will make it 0. So already I have these two zeros. I am doing for this. Now for 2, what will be the result? Result will be, it is larger than this, but it is smaller than this, and hence result for this will be also 0. Then I will go here. Then I will go here. I will check left and right. Right? So what I obtain, it is a maximum one, and hence my result will not be changed. Do not suppress if it is a maximum. Suppress if it is not a maximum. What will be the result for this? What will be the result for this? I have to compare with the original only, right? Not with the modified. If I am checking for this, then it will be 0 again. Why? Because it is smaller than this 3. And if I will check it here, then it will be smaller than this 2. And hence I have to write it like this. Right? And then if I will check for this, it is 0 anyway. So, but of course it is smaller than this, so it is going to be 0, and this 0 is 0 itself. So in that way, if I will repeat, so I will obtain like next row. If I will do, I am going to obtain the same thing like this. I hope you can see the thin edge now. This is what non-maximum separation is. So this is my vertical thin edge of 1 pixel thick, and that's how I will meet the objective required by the Canning edge detector. Okay, but here very interesting observation if you have, it was a vertical edge and you compared in horizontal direction. Can I compare it in vertical direction? No, I should compare, I should apply this non-maxima suppression. I should suppress the values if they are not maximum in horizontal direction. Why? Because my edges are vertical. That means I should apply non-maxima suppression in the direction of alpha. What was alpha? It was orthogonal to the direction of my edge, right? So by direction of edge is vertical. That's why alpha will point to horizontal, and I should apply this non-maximum separation. That comparison I should apply in the direction of alpha. Okay. So if it is horizontal edge, I will apply non-maximum separation in vertical direction. If it is vertical edge, I will apply non-maximum separation in horizontal direction. Diagonal, then you can understand other diagonal direction. But what if my object is placed like this, or not like this even, it is slightly tilted, it is not horizontal, it is not even diagonal, then I should apply, I cannot apply, see it is my pixel only, so I have 3 cross 3 neighborhood. How will I check the non-maximum separation here? So for that we have a solution that if my alpha falls in any of this range, right? If alpha falls in any of this range, then consider them as 0. Alpha is 0, that means that is it is pointing towards vertical direction, or that is x direction. If my alpha, that means if my edge is like this, right? So my edge is like this, so my alpha will point here. It will not be straight vertical line, it will be slightly tilted vertical line. So if it is slightly tilted vertical line, that means it will fall somewhere here, and hence this region this entire region is considered as 0. So that what we are actually doing, we are approximating slightly tilted to a horizontal edge. Here this is, you can say, okay, you can assume that it is a horizontal edge, right? How to assume? By confirming that alpha is in particular range. So what is that range? Minus 22.5 to plus 22.5. If it becomes, we will consider it as 0. From 22.5 to 67.5 it comes, then we will consider it as minus 45 degree. That means you will consider the difference in this direction, you will consider difference in this direction based on, because I can have difference either vertical or horizontal or diagonal only. Other operations I cannot have. That's why I need horizontal edge, I need 45-degree edge, or I need vertical edge. So if my angle falls in this direction or in this direction, here, my angle will point here, na? My angle will point here, but that is also horizontal edge. So whether it is in this region or in this region, consider it as a horizontal edge, and so on. I hope you can understand it, right? So first of all, what I have to do, because that's why the gradient was applied, because alpha can be used here, no? That alpha can be effectively used, right? So what will happen now? You will have one image. Suppose image is given to you. Then what you will do? You will apply Gaussian. Then you will apply the first order differentiation. Any mask you are applying. Suppose you are using Sobel mask. Suppose you are using that for the gradient. So now you have your edges. Then what you will do? You will check your alpha, because you have gradient. You will have your alpha. Then if alpha is in the particular range from minus 22 point plus 5 to plus 22.5, consider them 0. In that way, you are going to round it off for entire alpha, right? And then if you identify that alpha is 0, that means you have to take difference in vertical direction. Alpha is 0, that means your orthogonal direction is in vertical direction. That means your edge is in horizontal direction. That's why you have to take difference in vertical direction, and you will start finding non-maxima separation applying. You will apply it for vertical direction, not for the horizontal direction, for all that alpha. Okay, so that is what this two steps says, right? If it is my value is at less than any one of its two neighbors, then make it 0. Otherwise, keep it as it is. That is what we did. So this is what non-maxima suppression is. Now, so here three steps are applied. Here three steps are applied. First Gaussian, then gradient, and non-maxima suppression. What will be the output of non-maxima suppression? This three values. What is three values? How we obtain three values? From this. What was that? This was actually my m of xy value. Na? We check. I check that my thicker edges are detected, but where I will find? I will find it in m of xy. So I obtained that three. Somewhere, if I will apply the same operation somewhere other, so I may apply. I may get 22, 225, 225, 225. That type of edge is detected. Possible 225, 225, and 225. What is that? Suppose in this region I obtain 3, but in other region detected edges are such that non-maximum suppression result into 225, 225, and 225. Single line, as it was single line here. The values are just, instead of 333, they are 225, 225, 225. Which values are they? The values are magnitude of edge. What it indicates? What is the difference of my current pixel with respect to its neighbor? If difference is higher, that means it is highly associated with the edge. That means this is the edge, fine, but it is not as strong as this edge. So possibly if I want to take some dominant edges, I don't want to take all the discontinuities in my image. I just want to find out dominant edges. I have to apply threshold. After applying non-maximum suppression, my results will be single line edges, and the values will be m of xy. M of xy can be smaller or larger, right? I want larger value of m of xy in my application. So what I will do, how to avoid this and how to keep this. So I will apply threshold here. If the value of my response is greater than threshold, um, then keep that pixel as it is. Otherwise, make that pixel 0, right? Suppose I am choosing my threshold, which is very low in value. That means I am choosing my threshold 1. That means if my value is greater than 1, keep it as it is. Otherwise, make it 0. So can I say this also will be past threshold? This will also pass the threshold. Low value of threshold always result into false positive because this was not the age or this was not the required age, and because my threshold was low, I had the false positive. And someone will say, no, I don't want false positive, I will go with a very large value 250. Then even this will not pass. So I cannot have threshold. So here it will be false negative, right? So this was the age, but it was not detected as age. That was the issue. So now how to solve this, both the issues? Like I have to choose my threshold in appropriate manner. If higher the value of threshold, that means I am finding dominant edges, but I cannot ignore smaller values as well. So for that, I am having one more methodology for thresholding, one interesting methodology for the thresholding. I will use two thresholds, and it is known as hysteresis of thresholding. Hysteresis of thresholding I am going to apply. What is that? I will take TL and TH, low threshold and high threshold, two thresholds. What is the ratio of high to low? 2 to 1 or 3 to 1, that depends what is your requirement, right? So higher threshold can be 2 times or 3 times larger than the lower threshold. Now what I will do, I have my image in which non-maxima suppression results are there, like results of 3, 3, 3 and 255 to 225, 225, 225 is there. This type of edges are existing in my image. Then what I'm doing, I am applying higher threshold. What is higher threshold? Suppose I'm taking higher threshold as 200. Then definitely this is going to pass, right? And it is going to pass. Then um, what will happen? Then I will have a lower threshold, right? Then what will be that lower threshold? Suppose I am keeping that lower threshold as 100, right? So definitely this, because this was not my true age, it will not pass. Okay. So I am creating one image G of NH, which is having all the points of G having value larger than threshold. That means all these points. That means G and H includes all the points that are potential candidate of age because they are having higher value of They are passing higher value of threshold. That means they are more isolated from their background. That's why the difference is higher, and hence they can pass the higher threshold. Right now, suppose, and then I am having one more image, that is GNL. What is that? All the images that are not passing lower threshold. That means here, all the points which are weakest are eliminated. In this G and L, I will have all the points which are which can pass higher threshold, as well as intermediate values from 200 to 100 as well. But all the values below 100 are eliminated. That means they are not at all potential candidates of age, right? And that way, higher threshold and lower thresholds are applied. Now, what I will need, I want, see, I know if my pixel has passed the higher threshold value, that means it is very strong candidate of age, and I want to keep them as it is, right? I'm wondered about all those values which are lesser than higher threshold, but greater than lower threshold. Intermediate values I'm worried about. If the intensity is even lower than lower threshold, that means they are not at all part of my age. I am confused. I don't want that false positive and false negative issues, and that can happen because all the values which are intermediate to this 200 and 100, that I want all those values which are so GNL includes what? All the values which are greater than 100, and hence it also includes all the values greater than 200. But if I'm subtracting GNH from it, what is the meaning of that? I'm subtracting all the values which are greater than 200 from it. So now what my GNL includes? My GNL has all the values which are intermediate to 200 to 100. In short, I had GNH, which has all the values greater than higher threshold, and GNL, which has all the values intermediate to in between TH and TL. How to implement is a separate issue. They have shown this implementation. You can go with your implementation as well, right? So, so now this includes the confused state. This includes all the ages where we are confused. Here we are confident that they are ages. Now what to do? So now what I will do, I will suppose consider the image like this. See, it is 2 to 5, right? It is 2 to 5 further. Then it is 100, or rather I should say 99, whatever you consider, 99, not 199, it is 99. Then 99, and this 2 to 5 again, right? So why these two pixels were having lesser value? Because possibility of noise, possibility of illumination issue. They are part of the age. Actually, this is my total age, but their value is such, it is smaller because of an illumination issue. And if I will just apply higher threshold, I will get this 2 pixel as my age, and this further pixel as my age. I will have a break between my actual age. I want to avoid that breaks. That's why I'm going for hysteresis of thresholding. That means this is actually my age, but I want to avoid this false negative. They are age, and I want to detect them as age. Right? So what I did, I applied first higher threshold. So if I will apply higher threshold, my result will be 225, 225, and then 0, because it will not pass, and then 225, right? Like this. Okay, and this is what my G and H. This is my G and H. What will be my GNL? GNL is actually all the values which are intermediate to here you should take 199. It should pass the lower threshold at least. It should pass lower threshold at least, right? So it is passing all the values which are passing the lower threshold. Then that will be 119 and 199 and 199, right? So these two values are from GNL. Why? Because it is in the intermediate range of 100 to 200. In case it is 99, again it will be 0, because they will not pass even lower threshold. Okay, so this is what my GNH and GNL. Okay, now what I have to do? What is my operation? I will take non-zero pixel of my image. I will check 8 connectivity of my that non-zero pixel of GNH, and I will observe in is there any value in GNL, non-zero value in GNL, which is in 8 connected with this 2 to 2. 225. That means I will check in my GNL. What is my GNL? It is 0 here, 0 here. I will look at this. I will check this location, this location, this location, 8 connectivity location in my GNL where my this pixel is non-zero. I will check that location in my GNL, and I will check 8 connectivity in surrounding. Is there any pixel which is non-zero? If yes, then mark it, otherwise not. Here, if I will see this is the location, the same location in my GNL is also 0 and its 8 connectivity is also 0, so I should not mark this pixel. But when I will come here, then I will come to this pixel in the same GNL, same location. I should check its 8 connectivity, and yes, I will find this pixel as non-zero. Then I will mark this pixel, right? Then I will then same way I will repeat that. So what actually I am finding? I am finding any pixel which is in 8 connectivity with my non-zero pixels in GNH, and is it exist in GNL? That means, is there any pixel which is in 8 connectivity of my actual age and it is not detected because of higher threshold, right? If it is connected, that means it is part of your true age. And in that case, if you can mark all the such pixels which are in 8 connectivity of your this non-zero values of GNH, and you can mark all those pixels, and you can combine those values, GNL and GNH, you can finally combine so that your finally detected age will be 225, 225, 119, 119, and 225. So what is the idea? And the idea says, what you have to take, you have to you will take your m of xy, that is all the ages you will find out. Then you will apply threshold, which is higher threshold you will apply, so prominent ages are detected. Then you will apply NL, you will find out NL. What is that? The values intermediate to between these two thresholds. And third point is, what is that? I have to check, I have to visit all non-zero pixel of my GNH because they are potential age, and I have to see whether is there any pixel in its surrounding of my stronger age and it is part of my GNL. That means weaker age, but it is a age, not weakest age. If it is in 8 connectivity of my stronger age, possibly illumination issue or noise issue has created that trouble. And that's why I should consider it as part of my G and H. Right, so that is the algorithm. You can read it. Implementation, not necessary to apply like this. You can have your implementation in your way, but concept should be the same, right? So now result time. So what we will see, so this is my image. If I will apply, if I will detect the ages using threshold and gradient, if you remember threshold and gradient method we have discussed, and we concluded, okay, this is breaking, this is broken, and I am getting this decent one, right? Then this was the result of Mar-Hilrath, and you can see here it is broken, but it is the best case in the Kenny, right? Here it was not available, here it is available, that age is available. So best age detection is happening, or better quality, not best, I should not say best, but I should go with better quality ages are found here. But definitely, what is the disadvantage? The computationally, it is heavy compared to other implementations. Same thing you can check. This is my image. This is my thresholded image, thresholded gradient, and you can see this area was not detected. Here somewhat detected, and here totally detected, or very nicely detected. So that is all about the King edge detector and advanced edge detections, right? So any doubts so far? Okay, so I'm concluding the lecture here. We learned today two advanced edge detectors, Mar-Hilrath and Kenny. Any doubt in case, you can ask me anytime.
Good afternoon, everyone. Am I audible properly? Hello. Good afternoon, everyone. Am I audible properly? Please reply. Okay. I'm sharing my screen, everyone. Hello. Is it visible properly, everyone? Hello. My screen is visible properly. Okay. Okay. So, listen, everyone. Today's lab aim is study compound object and functors in prolog. Study compound object and functors in the prolog. Now, see, in this particular lab, first of all, I will explain you what is that compound object. But see, just I will give you a brief overview. See, total 9 pages are there, right? So I will give you a brief overview. I will not explain you the program portion because in exercise portion, the same program you have to take, but just you have to do the modification. Just wait, everyone. The aim is study The aim is study compound object and functor in the prolog. The what is compound object? The compound data object that allow you to treat the several pieces of information as a single item in a way in such a way that you can easily pick them apart again. See here one example is given. See everyone that is consider for instance the date. That is see here it is given month, day, and year. So it consists of three. The date field that consists of three pieces of information. But it is useful to treat. But it is useful to treat the whole thing as a single object. So here instead of writing these three individuals, it's the whole thing you write in a single object that is a date object. So how you can write in a prolog? So you can do this by declaring the domain containing the compound object date. So see here in this case, you can write in this way. Instead of writing this individual three month, day and year, what you have to do? You have to create a one compound object that is date and then in bracket in domain portion, see the month that indicating string, day that indicating integer and this indicating integer. In this way you have to write. And then you simply you can write in this way everyone. So here in this case, you can say that it always this looks at a prologue and see here you can say that always it begins with a name usually called the functor. And in this case, you can say that this the date is a functor and it is followed by three arguments. The date is a functor and it followed by three arguments. So this is an example. This is an example of compound object. Instead of writing this month, day, and year individual, what you have to do, you have to treat the whole thing as a single object, means like a tree-like structure, right? This is the concept of compound object. In this way, you can define. Now, the another thing that I want to tell you that is the argument of the compound data object can themselves be a compound. For instance, you might think someone's birthday as an information. See, here in this can say that, see, a birthday, in this structure, I can say that person and date. So the person is Apurva Mehta and date is this date is given. Okay. So in prologue, how can you write? So here you can say that the argument of the compound object can themselves be a compound. So here in this case you can say that see birthday. Then in bracket I have written these two objects. So here you can say that the compound object is birthday. So there are two parts to a compound object birthday. The object person, which consists of first name and last name, and date, the object that contains a month, day, and year. Okay, so here you can say that the functor of this data object are what? Person and date. Okay, I think all are clear. Uh, Hello, now my voice is clear to you? HV, Rutvik, it's not clear. Just wait. Hello, Rutvik, Jainik, HV, Gata. Now my voice is clear to you, everyone, or it's not clear? Hello, please reply so I can understand. Just wait, I will check. Hello, now it's clear or still it is tracking? Hello, hello, HV. Now my audio is cracking. Hello, Gata, Jainik. Just wait, everyone. I'm changing my network. Now my voice is everyone to you. Hello. Am I audible properly? Hello. Please reply. Hello. Hello, everyone. Now it's clear to you, everyone. Am I audible properly? Okay. Okay. So let's start. Can I start from the beginning? Okay. So I will start from the beginning, everyone. I'm sharing my screen. Now my screen is visible. Gata, Sachin. Now my screen is visible to you. Okay. 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 So let's start with our lab, everyone. So aim is to study a compound object and function in a prolog. See, basically, why we use compound object? The compound data object that allow you to treat the several pieces of information as a single item in such a way that you can easily pick them apart again. See, this example that I have shown you, that is, consider the instant this date, that is December 10, 1989. It consists of three pieces of information: month, day, and year. So, but see, here in this case, it's useful to treat the whole as a here. It is useful to treat the whole thing as a single object with a tree like structure. See, instead of writing individual month, day, and year, what you have to do, you have to treat the whole thing as a single object. Okay, so this is the domain that containing the compound object. So here the compound object is what, date. So how to write? So in Prolog we can write in this way. See, date is a compound object. In this and in the bracket you have to in argument you have to write this three information. So here the month that is string, this the day indicating here integer, and the year is of type integer. Or you simply write like this. So here you can say that it begins with a name usually called a punctual. In this case it is date. And it's followed by a three argument. It's followed by what? Three argument. Now the other thing, see, just I will give you a brief overview, and based on that, see these two the this particular lab I have uploaded in a Moodle as well in Drive. Also I have shared. So after that, open that everyone, and see in that one program is given, but the exercise just you have to in the same program you have to do the modification. So you have to understand the program by yourself, everyone, and you have to just do the modification. So the exercise is very simple. Now the another is the argument of the compound object can themselves be a compound. Again, the argument of the compound data object can themselves be compound. See here in this case you can say that here the birthday that is a count object, and see here in here I have written the person and date. So here I can say that there are two parts to a compound object birthday. The object person, person which consists of first name and last name, and the object date which consists the month, day, and year. Okay, so you can say that the functor of this data objects are person and date. These are the what functor of the data object. Now my voice is clear, everyone. Is it still cracking? Okay, now it's clear, everyone. Hello, hello. Okay. Now the next topic is unification of compound objects. How the unification of the compound object is done. Now see, remember the compound object can unify either with a simple variable or with a compound object that matches it. These two things, the compound object can unify either with a simple variable or with a compound object that matches it. Okay, so here this means you can say that you can use a compound object to pass a whole collection of items as a single item and then use the unification to pick them apart. See here one example is given. Let's say this is a compound object, right? Now so here it matches with the simple variable that is x. Then you can say that it bind x to a date, it bind x to this compound object. So either it can unify with the simple variable or unify with the compound object. Now another the thing that is given, so if suppose it is unify with this compound object, so now you can say that it is bound to MO is bound to April, DA is bound to, because this date and date both the objects are matched, the unification is done. So here you can say that MO is bound to April, DA is bound to 14, and year is bound to 1960. Okay. So in this way, the unification of compound object is done. Now, since the sample program is given everyone, given to you. So here you can say that the person is a compound object. It contains the three things, three argument it contains. Okay. So now here, here see Go rule everyone. So in Go rule, one of the compound object is given. Okay. So here, when I write go, so what happens? So first, it will call this compound object that is first. So now here, from that it will call this in this particular premise what it will call this fact. So what happened? It goes to here. This thing is not matched. So directly what Apurva meta is matched. Then here is the anonymous. So that means here it ends here. And an address. So that means this particular thing is bounded everyone. Okay, after that in the next compound object what is? So here one notation is given that is name not equals to Apurva. That means which so what will be the output of this code? So these two are matched everyone. Name not equals to Apurva, and here the engineer is that, and that's why you can say that the result is what Mrunal set and Sachin Bhatt. These two result it will show everyone, and after that it will show you because of fail it will show you no. Right, so is in this way the compound object means unification is done, right? So Another purpose of the compound object that I want to tell you, that is, see this particular fact, everyone. Okay, on here I have written Apurva, comma book in bracket Parva, comma SL uh, Bhairappa. So here in this, in which you can say that the Apurva all the book Parva written by this particular author. Similarly, if you could write, see, here it is written. Similarly, if you could write on Apurva or Blackie, so which can be interpreted as the Apurva on the horse named Blackie, right? So here, see why I will show you this type of fact, because by using this I want to show you what is the use of the compound object. Now see, instead of writing these two facts, listen again I repeat, instead of writing these two facts, if I if I write on Apurva comma Parva and on Apurva comma Blackie. See, here in the previous fact what happened, this book and horse, these are known as a what? This book and horse, these are known as a compound object. Means all is a one compound object. Within that, another compound object is there. So the book and horse is a compound object. Now, instead of this fact, if I write on Apurva, comma, just I write Parva. And in this fact, if I write on Apurva, comma, Blackie. So here, if I write the fact like in this way, then what happens? You would not be able to decide whether the Blackie was the title of the book or the name of the horse, right? And that's why here you can say that that's why there is the use of compound objects. See, if you are writing in this way, then you would not be able to decide whether the Blackie was the title of the book or the name of the horse. It would not be able to decide, and that's why this type of compound objects are useful, everyone. Okay. So remember, compound object consists of a puncture and the object belongs to a puncture, right? All of you now know this. And then the important feature of the compound object allow you to what? Easily pass a group of value as a one argument, right? This is the important feature. Now, right? Now, I think all of you clear that. And another is consider a case where you are keeping a telephone database, everyone. So in your database, you want to include all your friends and family member birthday. So then this compound object is useful, everyone. Compound object is useful, everyone. Okay. Now then I will see here one sample code program 2 is given. But listen everyone, this program that I will not explain you. So see here, here in this page, in the exercise, what you have to do. In exercise, the same program is there, but see, just you have to do somewhat modification, right? So I think all of you clear with the compound object, right? What is the use of compound object? So you have to understand the sample program 2 by yourself, read the theory portion, right? In that description is also given to you, and based on that, in this program, just you have to do the somewhat modification. Okay, and second program is also very simple. So do by yourself, everyone. If you have any doubt, then please ask. Hello. Any doubt? What is about compound object, everyone? Hello. Is there any doubt, everyone? Okay, so I think all are clear, everyone. So now please reply. Are you getting this particular lecture file? Are you getting this file from Moodle as well as Drive? Hello. Are you getting this, everyone? Or no? Is it accessible to you? Moodle is accessible to you, everyone? Gata, Sachin, Dipesh. Hello. Okay, so okay, everyone. So there are 9 pages. You have to read it, everyone. And after that, based on that, the sample program is already given. Just you have to do somewhat modification. Do it. If you have any doubt, then please ask me. Okay, so now do it by yourself, everyone. Read it and implement it. If you have any doubt, then write down your question in chat window, everyone. For lab 6 and lab 7, I will put the deadline on Moodle on next Friday. Listen, next Friday you have to submit me lab number 6 and lab number 7. Both the lab you have to submit me. I think for lab 6, see, I forgot to put the as deadline. So what you have to do? Okay, now not on Monday, but see both the lab you have to submit on Friday. I think because actually this Friday you have to submit everyone. Means today you have to submit that lab C, right? But the deadline is remaining, so the both the lab you have to submit on Friday. So on Moodle, I will put the deadline on it. Gata, your assignment 6 is ready. Hello everyone. Okay. So listen, next Friday. Next Friday you have to submit both the lab number 6 and lab number 7. Okay. So right now I am uploading it. So after that, refer to it everyone, and at that time you have to submit. some of the students have not submitted me left 4 and left 5, right? So I will not tell the name of that particular person, but see, all of you means you know that the particular student know that submitted the left. See, please submit it on time, everyone. It will affect on your term work marks, right? This meant every time I don't want to say it again and again, but please submit it on time, otherwise it will affect on your term work marks. Read out, everyone. Is there any doubt, everyone? First program is done. Kashyap, Gata, Dipesh. First program is done, everyone. Is there any doubt? Please reply.
Hello, Dipesh, first two programs are done. Okay, good. Talking about third program. So just Dipesh, in the third program, just you have to verify this link and you have to check only. Nothing you have to do. Okay, so in assignment, listen everyone, just you have to write first two programs. Is it okay, Dipesh? So in assignment, you have to write first two programs only, everyone. Please refer to it, everyone. As well as also, I am uploading the lecture contents today. So also I will upload that. So please also refer to that, everyone. So up till now, whatever I have explained, that I will explain you in Moodle today. I think up to fuzzy logic I have uploaded. After the fuzzy inference, it is remaining. Any other? Everyone, how many programs are done? Kashyap, Jaimin, Jaini, Gata, Sachin, Yug, Rutvik, Hetvi. How many programs are done? Is there any doubt to anyone, everyone? Any doubt? If you have any doubt, you can ask me as well as you can mail me. Ashish, all the programs are done. Ashish, Dhaval, all the programs are done. Khantil, Prakruti, Priyank, Rutvik. Okay. Okay, Ashish. So, any doubt from your side, everyone? Okay. Okay, so we are ending our session over here. Thank you. Last 5 minutes left. We are ending.